You're looking at a Rigol Technologies DG4162. It's a 160 megahertz function generator with two equivalent channels. What we're going to show in this presentation or demonstration is the use of one of the features in the generator. And the particular feature we're looking at is a harmonic maker. With the harmonic function or maker, you have an opportunity to program as many as 16 harmonics and giving each one of them an amplitude and a phase. As you might imagine, to start the presentation, I've loaded into channel 1, which is on the left and is in yellow, the pattern 1, 1/3, 1/5, 1/7, and so forth. And as you realize, that would present, or that will make a representation of a square wave, and the 4162 will show that along the left side of its panel. And I've also got the 4162 connected to an oscilloscope where you're able to see that, yes indeed, it does make the kind of waveform that you would anticipate or expect. Now over on the right, I have also put in one of Rigol's spectrum analyzers, and this one happens to be the DSA 815, and you'll see that it is showing the 1, 3, 5, 7 type of pattern that is common in a square wave. But there are certainly many functions that you would want to generate with a harmonic functions, and there are a number of possibilities for storing waveforms in the DG4000 family. Here I'm going to push this store button and it will bring up a number of patterns that I have previously put into the instrument. The one I wanted to take a look at is this one right here, and by pushing the read key, giving it just a little bit of time to get ready, and you'll see that when we set that up, I ask it to output a function that has two equal harmonics, the first and the 16th in this case, or the first and the 15th harmonic. And you can see that the pattern is shown there on the channel 1 panel of the instrument. It shows on the spectrum analyzer as having the two equal waveforms, and then of course on the oscilloscope it's not difficult to see that there are indeed two frequencies present in the waveform. Now with this pattern, it's easy to illustrate how easily you can program the waveform. Now from here you can see that if I come onto the menu structure, I just press the down key and I have an opportunity to program the amplitude and the phase. And for the first part of here I'm going to go in and set the amplitude, and you'll notice that as I go through the various functions, I can look at the amplitude for the various waveforms. And indeed, you'll notice that all of the waveforms have been set there at 50 dB lower, and I'm going to come out here to the last one, which is the 16th, and you'll see I have asked that it be programmed at 0 dB. What I'm going to do now is I'm going to drop it by 20 dB, and that should be large enough that it will show up easily on the spectrum analyzer. I can set it to a number of different levels. In this particular demonstration, I've set it to express itself in dBm, and so by waiting for the waveform, you'll see that it indicates that it's not going to have very much signal, or it's quite a bit reduced. And indeed, if I look over here, you'll notice that it is down about 20 dB. And then I'm going to go back here and put the signal back. So simply by going into amplitude and then saying 0 dB, the waveform comes back. But now, as an example, I'm going to go back to the signal level, and let's go here to the 8th harmonic. Go to the amplitude, and let's put one in at 0 dB. And you'll notice that it proceeds to go through the patterns. And there on the spectrum analyzer, you'll see that it shows pretty much what we have programmed. And then over here, the pattern looks to be significantly different. So indeed, you can see how simple it is to set the various amplitudes on the waveform. There's another feature of these harmonics that I wanted to point out, and that's done most easily with another pattern that I've put in here. And you'll see when I bring it up that I think at least that it's a pretty interesting pattern, because it looks like that. And so you can see that the pattern looks similar there on the right of the screen, but it looks like a square wave, or it looks like something like what you would see over here. Now, one of the things that we did previously is we were looking at the amplitude. This pattern is pretty exciting or interesting because it gives you a nice illustration of how the phase can play quite a difference in the waveforms that you make. And you'll notice again that you can switch back and forth against the different harmonics, and if you look here at the phase, you'll see that every one is alternating. So I'm going to go here to the 2nd harmonic, and I'm going to go to phase, and I'm going to radically shift it to 0 degrees. Give the instrument a time to do its some more calculations and getting set up, and you'll see that the pattern does indeed show up to be quite different. And you can see that it shows that on the panel for the generator, and it shows up quite differently in time on the oscilloscope. And if I go back here, I can reset it back to 180 degrees and recover my signal. And pretty soon you'll see that we are back right there. And in this presentation, you'll see that all the harmonics that are present, but you don't, from the spectrum analyzer, get any information about phase. So that's some of the feature of the harmonic function that is in the DG4000s. You've seen that you're able to set as many as 16 harmonics, and you are able to set them for their amplitude as well as the phase. If the instrument were turned around, you would see that there is a connection for a LAN interface as well as a USB connection. Naturally, that gives you an opportunity to work the instrument either from a computer or from your network. If you have questions about the DG4000s, or if you'd like to discuss your application, we'd be pleased to speak with you. You can also get more information about the DG4000 or the rest of our products at our website, and that would be www.rigolna.com.